In this video, we're going to be talking about the time value of money. And in particular, we're going to be talking about the TVM solver on the graphing calculator. So on your calculator, if you click on the Apps button and then select Finance and TVM Solver, that brings up the TVM solver. On the right-hand side of the screen, we'll look at what all of the different things mean on the screen, and then we'll go through an example. So first is N, the total number of compounding periods per year, and that's also going to be the total number of payments. We then have I percent, which is the interest rate. We have the present value, which is whatever amount of money we're going to start with. We have PMT, which is going to be the payment, which we may or may not have depending on the problem. And we have the future value, which is how much money we'll end with. We also have the payments per year and compounds per year, which will always be the same for the problems in this class. At the very bottom, we have payment end or begin, and that will depend on the type of annuity that we're working with the problem. So let's look at our example. If Chris has $1,000 in an account earning 2.1% annual interest compounded monthly and deposits $100 at the beginning of each month, how much will the account contain after 2 years? So let's start from the beginning. First, we want to know the total number of compounding periods or the total number of payments. Chris is going to be making monthly deposits for 2 years, so that's 12 for the number of months per year times 2 for the number of years, so that's 24 total payments that Chris will be making. The percent is 2.1. Notice on the calculator it says I percent, so we want to type that in as a percentage rather than as a decimal. So we'll type in 2.1. PV, the present value, is the amount we start with. And so Chris has $1,000 already, so that's the amount that he's going to start with. Now in the calculator, money has to be directional. So if money is moving away from you, that's going to be negative. And if money is coming to you, that's going to be positive. So this $1,000 he has invested in the bank. So that's going to be a negative number. So anytime we invest money or put money in the bank, that's going to be negative. Our payment is $100. That's how much Chris is depositing each month. And again, that's an amount that he's putting in the bank. So that's negative $100. The future value is what we're going to solve for, so we'll skip that one for now. The payments per year, he's making monthly payments, so that's 12. And if we hit enter, that's going to copy that down to the number of compoundings per year, because those will both be the same for this course. Now in the problem, it says that he's making those deposits at the beginning of each month. So down here at payment, we want to switch that to begin. So if the problem says that payments are made at the beginning of a period, or if it says that it is an annuity due, payments will be made at the beginning of the period. If it says it's an ordinary annuity, or if it just doesn't say anything at all, we'll assume the payments are made at the end of the period. So now we can go back up to our future value, press the alpha button and then the enter button, and we can see that at the end of 2 years, Chris will have $3,491 and about 42 cents. And we'll notice that that amount of money is positive because that's the amount of money that Chris would be able to withdraw from the bank after those 2 years.